Dear students, now we come to the topic Le Chatelier principle. Its principle that states if a system in equilibrium is subjected to a change in any of the factors that determine the equilibrium condition of a system, then the equilibrium will shift in the direction as to reduce the effect of the change. I am telling you that equilibrium depend upon some factors like concentration of the reactants and products, temperature, pressure, volume, and addition of inert gas, catalyst. There are many factors. If any of the factor at that equilibrium, after reaching the equilibrium, if we change any of the factor, there may be the equilibrium to keep the equilibrium constant, remain constant. The reaction shift in either in forward or backward direction. The reaction shift either in forward or backward direction to minimize the effect of the change of those factors. Suppose first one we just going to explain the effect of change in concentration. Suppose now we take a reaction, the previous reaction, the Kc is written that Kc is written d to the power d concentration e to the power e by concentration of a to the power a and concentration of b to the power b. Now here we just in this reaction, if the concentration of a and b, if we increase, what will happen? To make the equilibrium constant, remain constant, the numerator will increase. The numerator increase means the amount of product will increase. That means it will favor the forward reaction. It will favor the forward reaction. Now, suppose from the reaction medium we are taking out D and E. So the D and E concentration become less. If the D and E concentration become less, to keep Kc constant, the numerator also have to be less. That means more and more A and B will consume and produce the product to keep Kc constant. That means it also favor the forward reaction. But if we add D and E in the reaction medium, then D and E concentration will be more. Then what will happen? To keep Kp constant, D and E concentration is become more. So D and E concentration should be less by increasing the concentration of A and B. Increasing concentration of A and B means the backward reaction will occur. So D and E combine together to form D and E. So backward process will be favored in that case. Is it clear? The effect of change of concentration. Now we come to the effect of change of temperature. Now effect of change of temperature, here we have two type of reaction. One is exothermic reaction where heat is produced. Another is endothermic reaction where heat is required. Now if we give temperature, now the applied heat, if we give apply heat, the applied heat will used in which increased temperature means we apply heat. The applied heat is used up in that reaction where that equilibrium is shift in that direction where the applied heat is required. Now here if we in this exothermic reaction if we apply heat, the heat is required in the backward reaction where C and D combine together to form A and B. So in case of endothermic reaction, if we increase temperature, the reaction will proceed towards the backward one. And in case of endothermic reaction, where M and N reacting together, we required heat. Now, if heat is applied to increase temperature, so that heat is used up in the forward process. So in case of endothermic reaction, applied increase of temperature will favor the forward reaction. Now we come to effect of pressure. Now effect of pressure, whenever we apply pressure to the equilibrium state, now the equilibrium try to reduce that excess pressure and shift the reaction in that direction where the pressure can be reduced. Here I am giving one example of nitrogen reacting with hydrogen produce ammonia. Now here in this forward reaction, you see one molecule nitrogen reacting with 3 molecule of hydrogen, that is 4 molecule of reactants, but the product become 2 molecule. The number of molecules decrease when the product is formed. That means when product is formed, pressure is decreased. So excess pressure will favor the forward reaction. Because in forward reaction, number of molecules is decreased, and number of molecules decreased means that the pressure is reduced in that direction. So whenever we apply excess pressure, the reaction will shift towards that direction where the pressure can be released. Now effect of volume is just reverse of the pressure. Just reverse of the pressure, because you know that pressure is inversely pressure and volume is inversely proportional to each other. So whenever in the case of pressure is there, the effect of pressure and effect of volume is just reverse one. Now effect of catalyst. Effect of catalyst, there is no effect of catalyst in the such equilibrium. Catalyst only helps to attain equilibrium faster, but addition of catalyst has no such effect in backward or forward process, because both catalyst speed up both the forward and backward reaction, and it just helps to attain equilibrium faster. Now effect of addition of inert gas. Now effect of addition of inert gas in reaction medium at constant volume, there is no effect, because at constant volume the volume is constant, so the concentration of reactant and product remains same. As the concentration of reactant and product remains same, so addition of inert gas at constant volume has no effect on the equilibrium. But addition of inert gas at constant pressure, the addition of inert gas at constant pressure increase the volume. If the volume increases, that means the product, reactant and product concentration decreases. Concentration of reactant and product decreases. So what will happen? So that will happen in that way that where the number of molecules increase, the reaction proceed in that direction. The reaction will proceed in that direction where the number of molecules increase. So the concentration remains same. So suppose the sulfur dioxide and oxygen, 2 molecules sulfur dioxide deactivate 1 molecule oxygen producing 2 molecules sulfur trioxide. If we add inert gas, the concentration of reactant and product decreases. So what will happen? The reaction will shift towards the backward one. So the number of here 2 molecules dissociate into 3 molecules. So number of molecules increase, and so the equilibrium constant remains same, and if equilibrium will be unaffected. So the backward reaction will occur in that case. But in dissociation of ammonia, you see that 2 molecules of ammonia dissociated into nitrogen and hydrogen, 3 molecules of hydrogen. So 2 molecules dissociate into 4 molecules. So if inert gas added there, the dissociation of ammonia will increase. That means forward process will proceed more, because in forward process number of molecules increases, which make the equilibrium unaffected. Is it clear to everyone? I think it's clear, the Le Chatelier principle. So it's complete of the equilibrium 1, and next I have to start the equilibrium 2, that is the ionic equilibrium.